Hi everyone, welcome back to my number sense series. In this video we're going to continue our fractions mini-series, this time doing addition. And with addition, we have two special kinds of problems that I want to focus on. The first is a kind of question where we get a over b plus b over a. In other words, a fraction plus its reciprocal. The second kind of question is where we're adding three fractions that all have a common denominator that's already in the problem. Now, I do want to focus though on the first one first because I think that is the most important one, and this one is the hardest to derive during the contest. If you get like this with bigger numbers during the contest, it's going to be like a huge time waste for you if you don't know the trick. Whereas for this one, you can kind of figure it out anyways. So I do want to do this one first. Now, I'm not going to lie. The trick for this is difficult to motivate. If you were just playing around with numbers, I think it's actually pretty unlikely that you would discover this by yourself. So I'm going to state the trick first, and then show you the proof, and then show you how it's used. So here's how the trick goes. If I have any fraction a over b plus its reciprocal, the answer is going to be, as a mixed fraction, 2 and b minus a squared over ab. That's it. Basically, it's 2 plus the difference between the numerator and the denominator squared over their product. Now here's the proof. A over b plus b over a. Now to add fractions, we have to first get them to where they have a common denominator. So we're going to write this as a squared over ab plus b squared over ab. Now this is just going to be, of course, a squared plus b squared over ab. And now here, we can separate something. We can write this as 2ab plus a squared minus 2ab plus b squared over ab. And now we can separate this 2 out to get 2 plus, and now we have a squared minus 2ab plus b squared. If you're familiar with algebra, you will know that this is a minus b squared. And that is how we prove this. So if you're looking at this proof and you're going, I don't understand any of that, that's totally fine, because for number sense, all you have to know how to do is how to apply it. But if you are looking at this proof and you're thinking, that's pretty cool, I agree. So now let's just get to applying it. 5 over 6 plus 6 over 5. Well, we know it's going to start with a 2 as a mixed fraction. And, during these contests, it's always going to be okay to write it as a mixed fraction because the problem writers know that you're going to use this trick. So they're not going to try to make it super difficult for you. So as a mixed fraction, it's going to be this 2 and something over something. Now that numerator is going to be 6 minus 5 squared. 6 minus 5 is 1. 1 squared is just 1. And the denominator is going to be just 5 times 6, which is 30. So that's our answer. And this is how you could write it in contest, and how you should write it in contest. Now, the next problem is going to be, pretty much the same once you know the trick. Once again, here's the trick. All right. So how are we going to do this? It's going to be, once again, 2 and 9 minus 7 squared. 9 minus 7 is 2. 2 squared is 4. So it's 2 and 4 over 7 times 9 is 63. Pretty easy. Now, for this one, try to beat me to it. Okay? It's going to be 2 plus 13 minus 10 is 3. 3 squared is 9. 9 over 13 times 10, which is 130. Not bad at all, right? So that is the first kind of problem, where you're adding a fraction and its reciprocal. And honestly, it's really, really easy to do as long as you remember this formula. Okay, now we have a also second kind of addition problem. The second kind of addition problem is really just adding three fractions. But it's not like they're randomly generating three fractions. The special thing about these kinds of problems is that you don't really have to find the common denominator, or at the very least, they're going to make it very easy for you because the common denominator is already in the question. So all you have to do is find the common denominator and then convert these using that common denominator. And oftentimes, it's going to be very easy. For example, here we have 5, 10, and 20. Now, obviously, 20 is going to be the common denominator. And, when you first see this question, you might notice, okay, wait, 5 times 2 is 10, 10 times 2 is 20. That's a little bit useful in this problem too, actually. Because in order to convert 1 over 5 to have a denominator of 20, we just have to know, what's 20 divided by 5? And obviously it's 4 plus 2 plus 1 over 20 equals just 7 over 20. So these questions are really just addition problems, just slightly simplified for you. Now, something a little bit similar with this one, but this time 8 and 9 are of course not multiples of each other, but if you are going to try to find the common denominator for 8 and 9, don't worry, it's already there. It's 1 over 72. So they tell you what the common denominator is, so let's just convert. 8 times 9 is 72, 9 times 8 is 72, so we're going to have 9 over 72 plus 8 over 72 plus 1 over 72. And what's this going to give us? This is going to give us 18 over 72, which actually simplifies to 1 over 4. Another thing you could have actually noticed is that 1 over 9 plus 1 over 72 equals 1 over 8. If you knew that, that's actually incredible. But if you didn't, this is totally fine. 1 over 4 is the answer. So those are the two main kinds of fraction addition problems that you're going to see in number sense. But remember, they are really just adding fractions at the end of the day. The hardest one has a really easy trick for it, and the easier one, well, it's already easy. So that's going to be it for today. Thank you guys for watching, and I'll see you next time.